Hi, and welcome to today's presentation of Fusion 360 Electronics. My name is Edwin Robledo. I'm part of the support as well as tech marketing team. And with us today will be Jorge Garcia, which is also part of the support and some of the tech marketing team as well. Give me one moment. I'm getting an echo on my earphone, so I'm just trying to just fix that really quick. Okay, I went ahead and I adjusted the volume as Sean was actually indicating that we should raise our volume for our presentations today. Okay, so I hope that's loud enough. Oh, okay, excellent. Thank you, Sean, for the comment. Appreciate it. So, today, Jorge, today I'm just going to go over kind of like an overview of a Fusion 360 and its design, electronic design capabilities. And we're just going to kind of follow along an example, a design example that I have. I'm just trying to look for it because being able to adjust my audio, I had to switch screens. So let me just go ahead and go back to where I was working with it. Okay, very well. So I'm currently at the screen I am right now. I'm actually just displaying uh, what Fusion 360 we're used to. I can expose the data panel, as you can see here. The data panel has subfolders, as you can see, and I actually have created a subfolder, or I'm sorry, a project folder is what I should call it, in which I will be actually working on our design. To be able to start your design in Fusion 360, your electronic design in Fusion 360, you need to go to the electronic editor of Fusion 360. So on the pull down menu where it says File, I'm going to go ahead and select the option New Electronic Design. This is going to take us to what we call the electronic document. The electronic document actually has quite a level of importance because it actually keeps track of anything that has to do with the electronic design. It keeps it together. It's the glue that kind of like make sure that the correct schematic is linked to the correct board. And why is that important? Any modifications that you've done on the schematic on the board, you want those changes to automatically happen or be informed between the schematic, the board layout, and the library as well. And the Fusion 360 electronic document kind of keeps all of that together. So the first thing we're going to do is that let's go ahead and start creating our brand new schematic, okay? So the create a brand new schematic, I'm going to click here where it says that the new schematic. And this is our schematic editor, as you could see. WorkCS has the interface exactly as Fusion 360 does. You have your different tabs on the top, which invoke the appropriate commands necessary, depending on which one you currently have validated or selected, I should say. You'll notice that the commands here, has the most commonly used commands for design when it comes to circuit boards as well as schematics. We're in the schematic editor for now. If you were already an Eagle user or you wanted to bring in an existing schematic, the only thing you would need to do is from the electronic document, the only step that would be different is that from the electronic document that you did create, if you're an Eagle user, you would click on this right here where it says it has that little link, and I would select the schematic that I wish to upload. In other words, don't upload your schematic first. You can do it, but it's best if you actually do it from the electronic document, select it, and it will upload it for you. If existing board based on that schematic, then you would go here and select that circuit board that you want to link to that schematic, okay? I'm not going through this exercise this time because I'm actually working with a brand new schematic. First thing that you always do when you're working on a schematic is actually kind of define your workspace. That's the first thing you should be able to do. So to be able to access some pre-made frames that we have, we're going to access the libraries. So I'll click here where it says add part. Okay, and you'll see that we have our parts here. I was practicing since last night, so I have some already components already selected there. And you notice that the add dialog box shows up. So let's explain exactly what's going on here on this add dialog box because there's a lot of information here going on. So you notice that it's divided in multiple columns. Okay, so here's the name of the library. I could expand that library and it shows and it will display the content of that library. As you are devices. The devices actually consists of the schematic symbol and the footprint that has been assigned to that component. If it has a 3D model, it will show up the 3D model as well. Now you'll notice that I have two footprints going on here. I actually have two of them. It's because this particular component has two footprint variants that I could use. As you could see, I have one and I have another one. Let me just go get another example that might be a little easier for us to understand. Here we have one that has a through-hole variant, as you could see here. This little symbol that you see here lets us know that it actually has a 3D model assigned to it. So we have the through-hole model, but we also have the surface mount version of it. Okay, so it actually has two variants. There will be some components that may have more than two. There will have 3 or 4 or even more, depending of the actual component. So first thing I'm going to do, so I'm just going to go ahead and find, okay, let me finish this. Manage folder. The ones that say Eagle PCB or Fusion Electronics, those are made by our team of developers. Other ones that are, yes, from managed folders that I participate with, let's say support team libs, it's one that we have internal. Now we provided access to our library management system to some distributors as well as some manufacturers, okay, and some other library services. So those will actually, you'll identify their names right here. So where it says the managed folder is because we made their managed folders for those distributors public. So you'll see here, these are for Fusion Electronics. And how can I access more of these libraries if I wanted to actually use them? What you would do is that you would click here where it says Open Library Manager. Show me how many of the components I currently have on my design. These are only showing up because I was actually practicing earlier since last night for today's presentation. These are the libraries that I currently have in use. In other words, every time I do the add command, these are the libraries that actually come up. And these are libraries that are currently available on our repository. As you could see, there are several libraries that are available. I'm going to organize it by managed folder. That's why you see me clicking here where it says managed folder. I'm going to select them by managed folder. And these are just some local ones that I actually have been working with. I use them for demos and so forth like that. This is another managed folder that I belong to as well. So if you work with a team or in a school, if you're a professor, you could actually create a managed folder and assign which libraries you want to share there on that managed folder. I go ahead and scroll down, you'll see that we have Adafruit, we have SparkFun, we have PCB Layout. They have a nice repository, a nice share of many components that we have. SparkFun and Worth Electronics as well has done quite a bit of a contribution. And I always like to make one observation is the ones by PCB Layout and the ones by Worth, the majority of those libraries include the 3D models, which makes it very convenient to have really nice, good looking boards. Okay, I'm not going to use any of these libraries for now. I don't think I really need them. I'm going to go ahead and click on cancel here. And here I'm just going to look for the frames library. So let me just find the frames library. They're in alphabetical order, so I should be able to find it here. And I'm just going to select frame, letter size frame. I like it to have the frame around it with the coordinates around here. And I'll go ahead and click OK. And notice that on my schematic page, we have this kind of this crosshair on the bottom in our page, okay, just to let you know. And we always work on the positive side of the coordinate system. So I'll place my frame right there, okay, and I'll go ahead and do a zoom to fit, as we do here. And you'll notice that I have another frame on my mouse cursor, which is kind of neat. I don't need it right now, but the idea is that if you were still using components, you want another, it's quite, let's say this passive parts like resistors, it's quite common that you're going to be using multiple resistors. So you click on one, you automatically get one on your mouse cursor. You click on the next one, you get, so let's go ahead and continue adding some more parts to here. So let's click on go ahead and I'm going to hit escape, and you're going to notice that that puts me back. Oh, should put me back to the add command. I guess it doesn't because I did some functions before I actually got there. So let's go ahead and find some other. 1 second. Okay, so here I'm going to use I'm going to use this power jack that we have. I used the search button to find my power jack that I needed. So on the search, I'm actually going to type * power, and with * jack, I'm using the wildcards. That way, I expand my possibilities of the component that I could actually use. Okay, I could have most probably done barrel as well. So let's go ahead and delete here and take barrel. Here's the one by barrel. I could have used this as well, but this one doesn't have a 3D model to it. So I'm just going to go ahead and use the power barrel one that I have. Okay, so I'll go ahead and click on that one. And now I'm just going to add this on one corner of my schematic really quick. Now I'm just going to put some additional components that I'm going to be needing for this power jack. I'm just going to go ahead and add some more of the parts that I need. I need to bring in some representations of power that is actually going to power up the schematic. So I'm going to actually be plugging in my power into this jack. And I'm not going to run a connection from this power jack to every component of my schematic. I'm just going to bringing it in and using this a symbol that represents power and distribute that throughout my schematic. So let's go ahead and click on escape. Let's go ahead and finish my. And now I'm going to go ahead and find my power connections here. So and I'm going to be using my VCC right here. I'll go ahead and place that right here on top. Okay, hit escape, and I'm going to go get some of my ground as well. I'll put 2 grounds down. So one is going to go here, and the other one is going to go here as well. It's my ground. And I just need one capacitor, which is going to, it's going to be like the capacitor it's going to act like a filter. So let me go to the capacitor library. Move it over. Okay, so let's I'm going to use this little circuit that I did here as an example to show you some other functionalities that we have. So when there's no command active in Eagle, if there's absolutely no command active, by default, the group command becomes active. Take a look right down here. You notice that the group command is the one actually being active. So for that, it's kind of a time saver. So if I want to move one component, you'll notice that each component has like a crosshair. That's the handle of that component. Without having to click on the move command, I could left click and hold directly on that handle and move that component. That saves me from actually clicking on the move command. Okay, so I could click and hold and move it. Now let's say I want to move this entire component. I could left click and hold on any blank area and define a group, as you could see. Now, if I want to move this entire group, I'll left click and hold on the handle of any of the components that belong to this group, and now the entire group moves. If you need to rotate it, I could right click it if I need to rotate it in increments of 90 degrees, okay? And I'll just go ahead and place it where I need it, and I'll left click just to place it. Now let's go ahead and define our connections that we need here. So I'm going to click on the net command, use the net command, do not use the wire command. And one rule that you should always follow is that when it comes to schematics, when it comes to component placement and defining your connections, you should always work on a 0.1-inch grid. It's extremely important that you always work on a 0.1-inch grid, okay? So I'm going to click on let me just turn on my grid. That way you see what's going on. Or the equivalent, of course, or the equivalent of a 0.1-inch grid, okay? So as you could see, my grid is 0.1 inch. So now I'm going to define and let me turn on that grid. That way you could see what's going on. Okay, in addition to this, if you're really new to Fusion 360 electronics, I would strongly advise in the meantime, because it provides a lot of data, I strongly advise that you actually turn on what we call the pin layer. So you're going to click on the display command here, and you'll see the list of layers that Fusion 360 actually has. There's one layer that by default we always have it disabled, which is layer 93. Okay, I'm going to go ahead and highlight that layer, and look what's going to happen with my pins. Okay, when I highlight that layer, you'll notice that these pins now get a whole bunch of new information. Let's explore that. Yes, a little bit. You'll see that each pin gets this little bubble on it. That's actually the dead center of that is actually the connecting point of that pin. It's letting me know that this is a supply pin. The characteristics of the supply pins is that they're not assigned to a footprint. There's no footprint. This is only a representation of power. So I'm going to have power plugged into this jack, and that is going to be called VCC. We're going to call it VCC, and then I'm going to take this VCC and distribute it through the rest of my schematic, okay? So I'm going to click on the net command here, okay? And I'm going to select, give me one moment. Okay, so let me just do a small modification here. That way this kind of lines up a little better. Lines up a little better there. So I'm going to click on the net command. Remember, not the wire command, the net command. I'm going to left click and just define my connection there. So you could see. Now I'm going to click here and select my connection here. Look what's going to happen when I intersect these two lines and I actually left click and stop the net here. You notice that the connection actually gets this junction point. That's just letting me know that the name of this net and the name of this net are exactly the same. That's what that's letting me know. So they're exactly the same point. Let's go ahead and continue defining the rest of our connections. So we're going to go here to here. Could have done this a little better, but, and there we go. Okay, and that takes care of our power jack. So this is how we're going to be bringing in power here. Let me go to the properties of this net. And when you connect a net to a supply pin, that net automatically adopts the name of the supply pin. This only works with supply pins and power pins, just to let you know. So as soon as I drew that net and I connected to the supply, it automatically adopted that name. I'll go ahead and check my ground over here as well. You notice that that net, since I connected to these power pins, those nets actually are carrying ground as well. Okay, let's go ahead and move on to some other parts. Let's just go ahead and try to bring in some other parts here to our design as well. Now, click on zoom to fit. Okay, I'm going to return to the add dialog box. Okay, and I'm just going to look for the at mega. Put the at mega 328. So we could see we have there. I actually prefer using the one by the Fusion Electronics manage folder. It has the 3D model already assigned to it, and it has the functionality that I'm going to actually be using for my design. Now click OK. And go ahead and place it here in the center here, and let me make sure that this, okay, yeah, that works. Okay, I'm gonna hit escape. Okay, and I'm just gonna, from the resistor libraries, I just need a couple resistors. I'll just put those down. So Actually, no. Sorry, I just prefer to use the US style ones. But that's just a matter of preference. That's all it is. Let's get some optoelectronics. Optoelectronics, here they are. I'm going to use the display command. Just turn off the value layer for now, because it brings in a lot of information. Also, I'm going to turn off the pin layer as well, because it just brings in way too much information that I actually require. Okay, and there's just one more header that I actually want to bring in. Just that way you see how I distribute some connections throughout my schematic. Okay, so I'm going to bring in a pin header. I got that error message because there's multiple variants that I could select from, and I did not select a footprint that I want to use. So I need to expand it and actually select if I want it straight or if I want it with a bend, with a 90-degree bend. Okay, I'll just bring in that one really quick. And I'll just rotate it. I'm using the left mouse click to just rotate it. And I'll go ahead and place this one here really quick. Now, there's some connections that I am actually going to be using from this header connector that we actually just placed. We're actually going to be connected to other elements. And this is, I just wanted to bring this up because this is a way to distribute connections throughout the schematic without actually having to connect to it. So let me just go ahead and click on the net command, and now I just draw my nets here. Okay, so my first one that I have here actually gets connected to ground on this header that we have here. So I'm just going to go ahead and right click it and select the name option and select GND. I'm going to use the option place label, and I'm going to go ahead and click OK. Yes, that is going to be connected to ground. It's asking me because I already have ground connections to my schematic. So that's what's asking me if that's going to be available. So I'm going to go ahead and click yes, that is going to be available. Now I'm going to go ahead and name this one where it's going to actually connect the CTS. Control. My VCC. My receiving transmitter. My transmission line. Oops. My transmission line. And my DTR. As you could see there. Now, you could either use the labels, put the labels there automatically, or I could just grab them. Let me click cancel. I could just select the label and actually just put it on top. Or what I do have here is I'm going to go ahead and select label on my selection filter. I'm going to select them all. And I'm going to select the transfer option that we have on the inspector. And you notice that now I get the nice port symbol. And if additional information on this line existed on different schematic sheets, it would actually extend that information. And I could just go ahead and move this and put them right there as well. So it's just one way of actually labeling your design as well. Okay. Now my transfer actually is going to, my transfer lines are actually going to connect to my transfer lines on the design I have here as well. So let me find them really quick. We have a reset. Oh, here they go. So here's my transfer line. So I'm going to draw my net. I could either, you have several options. I could right click. Oh, I have the filter turned on. It's not letting me select it. So if you're trying to select an asset on your schematic or on the board and you only hear this boink sound, is that it's not able to select it, and it's because it's not being allowed to because on the selection filter. So I'm going to reset my selection filter, and I could right click here and select the option name, or I could just go up here on the top toolbar and select the name option and just click there and select RX. And I do want to place the label. And here we have our transfer line as well, transmission line. Now click on name. Now you'll notice that, see if you could see it. I don't know if it transmit appropriately, but if I was to use the show command and select the receiving line right here, let's see if this will highlight. Yeah, I don't know if it's too faint, but on my end, I noticed, you see this, the pin highlights there, it goes to a bright red. You notice that over here, it actually turns on as well. So let me turn on the pins layer. That way you could actually see it. Okay. So let me try another one. We'll try the transmission line. So we click there. And as you could see, it actually automatically came up there as well. Okay. Now I would continue adding more and more and defining more of these connections as we go along. Use the net command and get our and some of these connections are actually going to be coming over from our at mega component. I don't want to continue here because if not, the whole presentation would go on this. So I do have the schematic fairly completed already. So let's go ahead and line that up. So this is what it actually will look like, our schematic. As you can see, this is my programming header here, and just using a regular 6-pin connector, a 2x3 connector for my my programmer header as well. And here is my just the pin header, as well as my LEDs as well. Okay. Now, with it completed, we're going to go ahead and create a circuit board based on this. Okay. So let's. So let's go ahead and click on switch to circuit board. All the components are going to show up on the left-hand side of an empty board, as you could see. The board layout, I was recently corrected by Jorge, letting me know that the default board outline is approximately 4 by 6 inches. Is that about right, Jorge? I think that's about right. Okay, so this is what, and we have our power jack here. We have our LEDs. Now, the board outline is a little.
Yeah, that's about right, Ed. You got it. Sorry, I was muted. I was trying to unmute. I was like running for the unmute button, but I couldn't find it.
You know, Jorge, yesterday I was in a meeting and several times I was like, and the mute button. It was underneath like 2 or 3 other dialog boxes.
It's horrible. So, sorry about that, guys.
That's okay. How's it going on the chat? I'm not really looking at it. I hope everything is okay.
Yeah, it's cool. I've been on top of it. So if anybody else keeps throwing questions, feel free to put them in there.
Thanks, Jorge. Greatly appreciate it. In case Jorge Garcia is support specialist as well as in our in our community manager as well, and he heavily participates on the forum. So if you post any questions on our forum, it's quite possible that you've gotten answers from him as well. Okay. So as you could see, I left clicked and dragged the board outline that came through. I'm not going to be really, really careful with my placement because I just want to optimize the amount of information that I get. Now I'm not gonna click on intentionally because I'm just gonna start moving my components. As you can see, the components come up with a little crosshair. That's the origin of the component, just as it does in the schematic. Okay, and notice that the background color of my board here is the background color of my board is different from the rest of the drawing area, and this is intentional. If by any chance at any point you're working with Fusion 360 and you don't have this color difference, you need to stop what you're doing so far. You need, if it's all white as you see here, you, don't continue working. It's very important that your board outline is an enclosed area. And this is true if you are Eagle users as well. If you're an Eagle user and you're going back and forth with Fusion 360 for your mechanical needs as well, it's very, very important that the board outline is actually an enclosed area. Okay, so I'm just going to go ahead and click on the line command. That way, just undo. That way I could get that back. Okay, so let's go ahead and delete this. And let's go ahead and draw a line.
Ed, you still there?
I'm here.
Oh, okay, okay. It went quiet, so I was worried something had happened.
Yeah. It's just I think you know what's going on, Jorge. It's kind of strange, but for some reason or another one, my keyboard is disconnected. So I was typing the, I have the bad habit of using the command line, so I was trying to.
That's a great habit, Ed. What you talking about?
I don't know why. It's just my keyboard is gone. I don't know why it got disconnected. I was just trying to just fix what's going on here. Where did my keyboard go? So, okay, I'll do my best without a keyboard. See if I can keep on and doing as much as possible with the mouse. Okay, so let's go ahead and start moving our parts. So you start dragging them here. I left click and drag to select the parts, and I right click to increment the angle in increments of 90 degrees. Now, you can use the move command and move components in virtually any angle as well. Okay, so it's just the convenience is quite possible. It's very common for you to be placing parts in only in 90 degrees. Now, can you use 45s? Actually, it's very common. I've seen many boards, especially for the microprocessors, to have them at 45. So just go ahead and add these parts here really quick. Okay, I put my processor here. I put my power jack over here. Bring the pin header over here. I'm rotating parts because I'm doing my best to have the components connected as straight as possible is what I'm trying to do. So you see me rotating them because I'm just trying to find the least amount of crosshairs, as you could see there. I'm just trying my best to have the least amount of those. That way I have like straight connections over is what I'm trying to do. Notice that when I get too close to the edge of the board, you see those couldn't touch there. That's just because Fusion 360 has something called live DRC. It's letting me know that I have a violation, and those hatch lines actually are telling me that that's the violation that I currently have. Okay, so as soon as I clear the violation, those hatch lines will actually go away. Okay, so let's find the origin here. Notice that the origin of the component is kind of being it's being hidden or it's being covered by this signal that we have here. So that gives me the opportunity to show you how to use the selection filter. I'm on the right-hand side, just to let you know over here where the selection filter is at. So I'm going to go ahead and select device. So no matter what I do, I will only be able to select parts from this point on. It's going to ignore anything else. It only lets me select devices at this point. Okay. So let me keep on grabbing some more components. Bring in my programming. Put it sort of, no, I want it over here. I think I want this guy over here. Put it over here. And then my resistors, I'll put the appropriate resistor that goes with the appropriate LED. Okay, this is just a rough draft of what we had here. So let me do a zoom to fit. Okay, all these air wires that you see, we refer to this conglomerate of all these air wires together is referred to as, a lot of times it's a rat's nest. That's what that's referred to. Now, as I was moving the components, they extended and contracted these signals, and now we want to optimize. We wanted to find the shortest distance, and the way to accomplish that is called the rat's nest command. So I'm going to click here with a little it's pour polygons because it's the same command for pouring polygons is the same one used for rat's nest. So I'm going to left click there, and it, as you could see, it kind of optimized a lot of my connections that I had here already. Okay, just move this out of the way a little bit. Okay. Now let's just take a quick look at what's going on here in 3D. Now that we have the 3D capabilities, why not just take advantage of it and take a look at what's going on at the board in the 3D realm as well. So I'm going to use the display command, turn off the value layer because there's a lot of information there that I do not need right now. Turn on the value, turn it off. Okay, so there we go. And I'm going to go to the electronic document that I have, and I'm just going to save what we have accomplished so far. And let's go ahead and move this on to a 3D PCB and see what's going on. I'm going to click on the View the 3D PCB. And that's what it actually kind of looks like, my board on the 3D PCB realm, okay, as we could see it. Now I could actually make some changes here if I needed to. I don't have any routing and no routing, so I'm not putting into risk any shortages or anything like that, even though we are going to do a small demo on how I can make changes, even though my lines are routed. But I'm going to take this jack, and I actually want it on the other side of the board. I actually want it on the other side. So I'm going to click on this option here, flip 3D PCB. It's right there. It says flip 3D PCB component, and I'm going to select this component. And it's actually now on the bottom side of the board. Let's go ahead and, yep, and click OK. It should be bottom now. Let's go ahead and flip this around, but it's looking the wrong way. So let's go ahead and kind of fix the way it's looking. It's looking the wrong way. It should be looking that way. Let's move it back a little bit, put it over there as well. Okay. I'm going to select the option that I have here for move. As you see here, it says update PCB. You see that there? I'm going to select that option. I don't have any routing, so I'm not going to select this option here. I'm going to go ahead and click OK. Okay, it's kind of really off to the edge of the board. So let's go ahead and move this again and fine tune its placement, bring it down a little bit more and click OK. I'm going to select update PCB. So what it's done is actually update the 2D PCB, okay, as well. And I'm going to show that to you in just 1 minute, how that all this is working. Let's go and take a look at, let's see what we've accomplished so far. Now let's go ahead and take a look at the board. What's going on the board? Just letting me know it wants to synchronize, and which it actually did already. Let's take a look at the board here. You'll notice that the pads of the board of the power jack actually went from red to blue, meaning that now it's on the bottom side of the board. It's actually now on that bottom side of the circuit board. And it actually moved the component as well. So whatever we accommodated, it actually moved the part as well. Now, a lot of times we get questions, Jorge, by users. I don't know if you've run this into the forum, but a lot of guys prefer to make modifications to the board outline in the 3D PCB. They just feel that the tools that they have in the 3D PCB better suited when it comes to board outlines. I think you've run into that a couple of times yourself. So
yeah, it depends on the background. Depends on the background of the person, but yeah, Fusion has more powerful sketch tools, and it's easier, especially if it's something complicated. Like here we have a rectangle, so obviously that's just as easily done in Eagle as it is done in Fusion. But if you have a unique board shape, or you have something a bit more specific, then obviously it makes sense to edit the PCB shape in Fusion, where you have constraints, you have fillets, you have trim, you have all these really strong sketching tools. It just makes sense to do it in Fusion.
Absolutely. Give me 1 second. I'm just trying to fix my keyboard here. Because without the keyboard, I am not able to do, I'm having a hard time rotating. Okay, I think I got it. I think I got it back. I don't have it back as of yet. Okay. Hang on. I have my mouse. I have my keyboard back. Okay, excellent. Whew, sorry about that. Now, let's say you want to make a modification to your board outline, and you want to just take advantage of using it in Fusion. Remember that in Fusion you have here, so I could go ahead and you have the measuring tool. I actually was using this the other day, Jorge, to just take some measurements of some assets because I actually wanted to move them in the 2D PCB realm. I want, but I wanted to take mechanical aspects of the design. It was just easier to do it in the 3D. So I took the measurements here and then I transferred whatever necessary modifications I needed to do in the Fusion 360 2D PCB. So it's kind of neat. So let's say, for example, you want to make a modification to this board outline, right? Let's go ahead and let's, on the timeline that you see down here, okay, I'm going to right click where it says the outline, the sketch here. I'm going to right click and I'm going to say edit the sketch. You'll see that the sketch actually comes up. And I'm just going to do some fillets. So a really quick fillet, we'll do it right here. It's kind of big. Oh, yes, just be more subtle. Do it at 4 millimeters. Okay. And I'll do just one more on the other side. I only want to do a few of them. Edit sketch. We'll do another fillet. These won't obviously actually show up. A little smaller. As soon as you click on Finish Sketch, you'll see that the board outline has been modified. And let's go ahead and just push this over to the 2D PCB by clicking here. That way we could see how easy this change actually took place. Actually, it's almost immediate, as you could see. Now, We have several routing tools that we could use to route this board. Let me see. I could maybe use this routing tool that we have here. Let me see if I could pull this one off here. Oh, as I said earlier, if you hear donks, it's just you need your selection filter. You got to reset the selection filter. So let's go here and I'll just use sketch routing that we have here available. Okay, so when you click on the manual route option, you get by default, you're going to get the walk obstacles avoidance automatically enabled. So in other words, if I start routing this line, it's going to automatically route on that layer. This is my active layer, okay? When you're routing, this is my active layer. This determines my active layer. Since this is a surface mount component on the top layer, it's actually just going to automatically go to the top layer. There's no other choice, okay? Now you notice that as we route, it's going to be as precise as our it's jumping from grid point to grid point. Let me go ahead and turn on the grid. That way you can see what's going on. You'll notice that it's jumping from grid point to grid point. So it's grid base, okay? So we may consider just lowering our grid quite a bit. Let me see, I'll bring it down to 5 mil. Okay, so we get a lot now more. The obstacle avoidance turned on, you'll notice that no matter how I try to go to a different pad, it will not allow me to, okay? It will always avoid it. If I disable obstacle avoidance, you'll notice that now I could go basically in any direction I want to go to. A lot of people actually like to have the power of being able to have going in any direction. So you really got to be careful that you're looking at your hatch lines. That way it lets you know that if you have any type of DRC, because DRC is live, okay, as well. Now we do have a nice lineup of manual routing tools. So you could do multiple lines with differential pairs, meandering, quick route. I'll show you how to use quick route really easy. So I could just click here where it says quick route airwire, and I'll select a line and it will try its best to route that line, as you could see there. And I could do it line by line. Now, do you want to do your whole board doing this? No, not really. These are just like straight line connections like this one. Why you kind of want to avoid it, because let's say for this one, it did the route, it kind of blocked these here. So if I needed to exit these pads here, I have virtually no space to go on there. So you got to be careful when you use it. So you be very cautious on using anything like that. It does work though. And there's just one more that I want to show you, and I'll do just a quick route here because I thought it's very useful. So I'm just going to do a route. I'm going to undo this. I'll do a manual route here, just because I just want to show you this feature because I thought it's pretty useful. And I've used it in combination with the auto router in the past. So let's say I'm routing this line that I have here. I use the route mouse key to use the opposite, the bend style. Okay, now if you want to use a different bend style, just go ahead where bend styles here, and you could use a different direction if you want. And when I finish my route, you notice that I get this X at the end, at the connecting point. That's just letting me know that's where I need to end. Okay, I'll just click there and I left click. I do have a violation, a DRC violation going on there because I had obstacle avoidance turned on. Now I'll go ahead and click on quick route, and I'll select the option here where it says quick route smooth. And if everything goes right, you'll notice that it actually kind of smooths that line for me. So there's been instances I actually use the auto router, which I'm going to use now. I've used the auto router and I come back and I kind of clean up a little bit what the auto router has performed using the smooth router, which is located on the quick route options. I'm going to go ahead and rip up the entire board and let the auto router take a look at this. Okay, so I'll click on quick route, select the auto router. This board is set up for 2 layers. So let's go and take a look at why is it set up for 2 layers. I'll click here where it says rules, DRC, ERC. DRC stands for design rule check. ERC stands for electrical rule check. And I'll click here where it says DRC. Many board houses provide you the DRC file for Eagle, and those DRC files that are available for Eagle are 100% compatible with Fusion 360 as well. So if you visit like, give me some names, Jorge, like OSH Park, PCB Layout, Screaming Circuits, you could actually download the DRC file from them and load it here.
Yeah,
Right.
your circuits that we have with us. I think even Worth, we have some Worth electronics.
Correct.
Design
Yeah,
files as well. You can get them anywhere. If the board house provides a DRU file, your best bet is to use it. If they don't, then you'll have to kind of configure it based on their requirements, which is a bit more work. But using, like I mentioned, OshPark, using PCB Layout, those already have Eagle DRUs that you can use, and that's just going to make the work easier for you.
Exactly, because it's going to set up clearances that they like to work with, or any other type of criteria that they prefer to use. That way you could get your boards back faster. If you stick to their criteria, it just translates to the fact that you're going to get your boards back a lot faster. Is what's going to happen. Okay, so that's the only reason why I wanted to bring that up. So if we go here and we go to examples and we go to design rules examples, yeah, we have from Euro Circuits, we have from Worth as well, and multi CB as well. We have some DR files that are already available for you to use on the design. Okay, now what's important here? Your layer stack up. Okay, and this is where your layer stack up. If it's really going to be 2 layers, or is it going to be 4 layers or 6 layers? Remember, boards are always going to work. Boards are always going to work in pairs. Okay. So if you look at a circuit board, you have your top layer and you have your bottom layer. Okay. So in this scenario, we're only using a 2-layer board. But if I wanted to go to a 4-layer board, and yes, in case somebody comes up with the question, can I work with 3 layers? You can. But no matter what, the board house is going to work with 4 layers. So it's just not going to put any information on that other layer, because they're always going to work in pairs. Okay. So we'll click here on the down arrow where it says 4 layers, and you'll see that now this changes to my top layer, layer 1, layer 16, and then 2 and 15. So it always works for the outer layer to the inner layer. That's the way it always going to work. And you'll see your setup right here. If you wanted to use blind and buried vias, in other words, vias that transfer from one layer to another layer and don't have any type of recognition on a different layer, you could set that up here. I'll just do one quick example. I have a 4-layer setup, and I have one from layer 1 to layer 2, for example. This is called a blind via right here. So it's coming from the top to the bottom and does not show up on the bottom. Now, I'm sorry, from the top to layer 2, but it doesn't show up on the bottom. It works really well, but just to let you know, it's going to, quadruple the price of getting your boards made. It's just to let you know, it's a heads up. So you want to kind of stay away from that if possible. If you're making a cell phone, 6 layers, and it has to be really tiny, of course you have to use it, but just take into consideration, it is going to be okay. So we're going to stick to a 2-layer configuration here that we have here, and go ahead and click apply. I'm not going to really do anything else. And let's go ahead and bring up the auto router that we had mentioned earlier. So let's go ahead and go back to design, bring up the quick route, bring up the auto router. Let's say I'm going to put effort medium. It just means it's going to, the effort, by increasing the effort, it just means that it's going to do more parallel runs of the circuit board simultaneously. Depending on how many cores you have, it's just how many it could handle simultaneously. I am going to leave it to select the grid itself. So it will select its own grid. And I do want the topological router to run. It's just an additional algorithm to our regular rip-up retry router that we already have. On top of that, it has a topological router in which it actually tries its best to route your board on a single side. Is what it's trying to do. Okay, so I'll click on and yes, select go ahead and start. Let's see how far we could get. For the effort level here, it actually is going to do 10 runs. As you could see here, it's doing a total of 10 runs. And as they complete, it will just give us a percentage as they complete. So the topological router, as well as all the other ones, are actually completed. It was able to do 97% maximum. So now let's go ahead and run ERC to see what it was not able to route. So I'll go over to rules, go to ERC, select DRC, I should say. I'm sorry, design rule checker, and I want to run it. Okay, I'll go ahead and click on check. And it actually, I only have one error. So it's an error wire. In other words, a line did not get routed. Now let's go ahead and take a look. I could double click it and kind of like it zooms in on it a little bit. So let's go ahead and seems to be a really, really thin line that you could barely even see it. It's right there. There's a line. So there's a routed line, and apparently that the way this is routed, it's kind of blocking it. So we would actually, kind of rip this up. Let me show you how to use the rip up command. You would rip that up. Just do a rip up. I would rip up a couple sections here. That way I could route that line. Let's see if we could just pull this off really quick. See if I could route this really quick.
Remember, you're in full manual, Ed, so you got a
that's right. It's allowing me. You're right. I have forgotten about it. Okay. So you know what? Let me just rip that up, clean it up a little bit.
You could use quick route for it too.
What?
That you could use quick route
right there. That's about right.
Yeah.
Oh, that's right. I could have had to use quick route as well. That's right. You're right. Okay. Now that my routing is completed and you've learned, you're now experts on using manual route, quick route options. Okay, and let's take a look at what's going to happen out of that 3D PCB. So let's go over here, and I'll be finished shortly. I know I'm at that 1 hour marker, so I'm going to try my best to finish. We did start like 2 minutes late, so it gives me like an extra 2 minutes. So I'm going to cheat. I'm going to take advantage of those for me. Take those 2 minutes. So this is what our board looks like now in 3D. It's kind of nice progress. As you can see, it's really easy as we could do. And there was one more nice feature I wanted to show you that we could do here. So let's say I want to move. Let's take this connector here, and it's horizontal. So let's go ahead and stand it up and see what would happen if we had the option to reroute automatically. I'll take care of this in 3D. So I'm going to click here on move. I'm going to select this component here that I have here. I'm going to rotate it. Rotate it like that. I'm going to move it over here.
Oh, my tired.
You okay, Jorge?
Yeah, I'm good.
Okay, I'm just looking at the backside to make sure I'm not hitting the jack. I'm so close to the LED. I want to do this. I always put it over here somewhere. It's close to the LED. Okay, so what I want to do is I want to update the PCB as well as I want to reroute. Click here and there and reroute. Okay, so I'm selecting the option right there. I hope everybody could see that there. I'm going to select the PCB and reroute and select both options. The idea for this is for it to actually update the 2D PCB, come back to the 3D PCB to do the updates. But in the 2D PCB, it's actually going to reroute. That way, all these lines that we have here will now have a new path automatically for us. So let's go ahead and click OK. Okay, and that's pretty fast. It actually works really well. As you could see, it accommodated the component. Place the component as it goes. I wouldn't do that there. I would actually fix this around. I practice for my next session. As you could see, now let's take a look at what happened in the 2D PCB. Okay, as you see, it was much easier to see here, Jorge. I really did a number on this guy here. So let's go ahead and move this part. Just put it there. I'll just put it right here. Violations are there, and I will select the reroute option in the 2D PCB, and I'll have it rerouted. I went ahead and fixed the routing. And let's go ahead and push this over the 3D PCB. That way we could see how it worked over there. The whole idea, the reason I'm doing all this is I want you to be able to see that you could work on it from the 3D PCB or the 2D PCB. So this is not to make it look good, okay? The whole concept behind is to have a high level functionality between the 2D and the 3D PCB. So even modifications done all the way from the schematic, which automatically update the circuit board, will all the way update the 3D PCB. So the cascade is very functional as it cascades throughout all of the editors, as you could see. Okay, so last but not least, let's just wanted to show, I was told that I should show, and I think it's very useful, is if you have multiple monitors, when it comes to the electronics in Fusion 360, you can undock the tab on the electronics. So I'm going to left click and hold the schematic, the circuit board I have here. You'll see that it actually separates. Okay, and I'm just going to put this over here to the side a little bit and stuff here. Okay, so I have my circuit board there, and I have my 3D PCB there, and I could keep on undocking. So let's go ahead and move this way a little bit. So here's the schematic. I could actually undock the schematic as well, as you can see. So there's my schematic. There's my electronic document. Here's my 3D PCB. So as you could see, I could actually kind of separate them. So it's very common for you to have more than one monitor. It's very common. Wink, wink, Jorge. So it's very convenient. Now this is possible now on the Fusion side, if I'm not mistaken, that will be possible really soon. But for electronics, we do have that capability already available. Last but not least, it would be a matter of creating the manufacturer. Oh, let me show you, how do you dock it back up? How do you dock them? See this little arrow you have at the end of the tab? I would just click on that arrow right there, and I would just right there, and it would just dock it back in where it goes. And I would do the same thing for the schematic. I'm sorry, for the circuit board, for the 2D PCB. And you'll notice that it docks there as well. Looks good. Last but not least, let's go ahead and create some manufacturing files for our circuit board. For this, I'm going to use the most simplest form. So I'm going to go to the manufacturing tab that you see here, and I am going to select the option right here that says CAM export right there. This is going to create all of my Gerber files for me automatically based on my layer stack up that I have in DRC, my design rule checker. It's going to create my top, my bottom copper, my component outline, which is the profile, my solder mask for top and bottom, solder paste top and bottom, silk screen top and bottom. It's going to create the pick and place machine and my bill of materials as well. And the pick and place is going to be for the top as well as the bottom. As you could see here, it's going to archive everything. It's going to zip it up in one file. So let's go ahead and click on OK. It's asking me, where do I want to put this file at? Okay, so it's going to my Fusion 360 folder that I have under Documents, Electronics CAM. This is the name and the date of my file. As you could see, it actually lines up the file of the circuit board. It's BBA, okay, version 4. Okay, it's BBA as well, and today's date. That's the way that's the format it's going to use. I could go ahead and click on Save, and it'll create that the zip file for me. Automatic, and so that folder, it is opened up on a different screen where that zip file is actually located, and you see it here. Last but not least, the only observation I wanted to do is that in the data panel, as I was working with Fusion all the time, of course, Fusion does versioning. So I could always come back and take a look at the different versions that I have of the circuit board, the schematic, the electronic document, the 3D PCB. Everything is actually being versioned. Therefore, if I need to go return to an earlier version because of modification that we do not want to adopt, you could actually go to the appropriate version, select that version, and actually promote it. It doesn't mean you lose your first version. It cascades to number 2 while this one actually becomes promoted. Okay. Well, that takes care of today's demonstrations. If you have any questions at all about what we covered today, please visit us on Fusion 360 Electronics Forum, and we'll gladly take care of them. And if you don't mind, put on the comments what topics would you like to see in future webinars about Fusion 360 Electronics. Jorge, thank you for everything that you've done today. Thank you for taking care of the chat. I greatly appreciate. As always, if you want to talk some more with Jorge, make sure that you visit our Fusion or our Eagle forums as well. I wanted to cover everything today. So, hey, thank you so much for everything. It's been a pleasure. And have a great day. And everybody, make sure that you stay safe. Thank you all.
Bye, everyone. Take care.